So for the experimental design and safety for lab number 1, I ended up, you have to find the copper gluconate, the chemical formula for it. So in this lab, what you do is you get the copper gluconate, you measure out to 1 gram of it, and then you're going to mix it with sodium chloride, and then once you do that, you kind of heat it up with 2 washers in it, and you're going to wait until the liquid turns clear, which mine didn't, or until the washers start bubbling on top and you can see like something forming on them. And so that's when I took it off. And then you scrape kind of that copper off of the washers and you put it on a cupcake tin, and then you're going to put it in the oven for 45 minutes and dry it out completely. So all you have left is no liquid at all in it, it's just the dried out copper, and then you're going to reweigh that. And then so I did all that for my lab number 1, and my hypothesis for that is going through the numbers of like the givens, and copper gluconate, the numbers that it gives us, it has a way bigger molar mass than everything else in that. So I'm going to guess that it's going to be a big amount of the 1 gram rather than the rest of the gluconate. The copper is going to take probably at least 1/3 to 1/2 of it when it comes out dried, just because you can see with the numbers it has like 64 grams per mole or something, where everything else has like 12 or 15. So that is my hypothesis. And for the safety part of it, we're working with an open flame, so make sure you're not using those rubber gloves that you're using the oven mitt to actually like touch the thing if you're going to touch it while it's hot. Light it and kind of step away, dispose of the match. Don't sit there, don't get near the fire. Make sure the flame's away from anything that could possibly catch on fire. Make sure you're wearing your safety glasses and you are wearing like some sort of non-synthetic clothing. Make sure it's kind of cotton so it won't burn up as easily. And then for disposal, we are working with liquids, so we want to make sure that we dispose of everything properly, whether it be if it's safe to pour it down the drain, or if not at all, then dispose of it properly like that. And we're working with hot liquids, so for that you're going to want to, before disposing of it in any way, you're going to want to take it off the flame and let it cool down for a while before actually touching it and doing anything with it. Just make sure it's completely cool, room temperature, and so you're not pouring hot liquids anywhere or burning yourself on the containers or anything like that. So for experimental design and safety for lab number 2, I heated up 3 different compounds, which was sucrose, sodium chloride, and it was stearic acid. And I got a stopwatch and saw how long it would take for each of the compounds to melt. And my hypothesis for this was, after reading through all the lab material, sodium chloride is the only ionic bonding, and since ionic bonding have more electrostatic attraction, I was hypothesizing that it's going to take longer, way longer than the rest of them to melt, because it has more of that energy that it would take to actually break down the bond, whereas for the covalent bonds it's easier to just break through them, and then the other compounds would melt probably immediately. And then for the safety part, so we are working with fire in this, and you just need to make sure to be cautious with all of that. Wear the right clothes, make sure to wear eye protection, don't wear the nitrile or the rubber gloves when you're doing it, because those are not fireproof. And also make sure to position the fire in a place where you're not like reaching over it or trying to get things around it, or might accidentally drop something into it, or don't put the fire in a place where it might touch anything else and potentially catch anything else on fire. And as for disposing of things, since we are doing it in the cupcake tin, make sure that the tin itself cools down all the way before you do anything with it. First of all, don't touch it, just set it off to the side and let it cool all the way. And then for the sucrose and then the sodium chloride, those things are easy. You can just throw them away. And then the stearic acid you want to dispose of properly. So everything is kind of easy to dispose of once you let it cool down. So results for lab number 1. First, to start off with, I did the entire lab, and then when I weighed the copper in the end, it said to make sure to take a picture, and my phone's pretty blurry, and I'm trying to show you on the screen, but it's kind of hard to see. But there's a picture. You can see that I got 0.3 grams of the dried out copper in the end, which kind of proved my hypothesis. Out of that whole 1 gram, 0.3 grams of it was copper, which was a pretty big amount. And so going through all the calculations to figure out what even the chemical formula of the copper gluconate even is, I went through, you can see it on my paper here, so I went through every equation and what the givens were and plugged them in, plugged everything in, and found it like step by step. I found like how much for carbon, how much for hydrogen, how much for the copper, and how much for the oxygen, and just like equation at a time, filling one thing in and then leaving one empty. And so in the end I got C12. I actually, like, for real got C12H21, Cu just 1, and then O14, but that's how it worked out with rounding. I got 21 because it was like 21.0 something, so I rounded it to 21, but when I actually tried to make sure I was in the right direction, seeing where I was, and I looked it up, the actual formula is C12H22, Cu1, and O14, so the only thing different is H. I got 21 and it said 22, so I'm not sure if it was just kind of like a rounding error somewhere in there, or what had happened, but I don't know. It was close enough to me, so I'm sticking with the actual one, which is C12H22, Cu, and then O14, and that is, after going through that process, those are all the numbers that I got. So the results for experiment number 2, which was trying to see which of the 3 compounds melted, took the longest to melt or took the fastest. It's not very pretty, but here are my results. They're kind of all written down on this paper, but I know how I wrote it down. I wrote it down in order. So the results I got was, I measured each of them out to 1.5 grams to make sure I was dealing with the same amount and every single compound. And so for the first one, sucrose, I got 2 minutes and 28 seconds, the time it took to melt completely, because I saw that a lot of it melted like right away, and then there's still like a little bit that was still there, and instead of just writing down that, I waited until every little bit of it was completely melted. So I got 2 minutes and 28 seconds for that. And then for the second one, for the sodium chloride, I waited for the entire 5 minutes and it had not melted a single bit, not that I could tell. So I just wrote down did not melt for that one, and I stopped it after 5 minutes. And then moving on to the next one, the stearic acid, also 1.5 grams like the rest, I got 31 seconds, and that melted immediately. It was like an instant reaction, and so that one was kind of like way faster than the other 2. And for the conclusions that I drew, so I kind of understood already by going through the pre-lab information that sodium chloride was the only one that was an ionic compound, but going through I really saw the difference between, yes, now I know for sure that ionic compounds are stronger bonds than the covalent ones, because that one did not melt at all in 5 minutes. I don't know how long it would take to melt, but the other 2 melted almost immediately compared to the sodium chloride. So covalent bonds are way weaker, it takes way less for it to get to its melting point, and so those bonds it takes less energy for it to break immediately.